Hi everybody, this will be 1.2 defining limits, and I will be discussing about defining the limits. So let's get started into defining how a limit works. As x approaches c, f of x approaches L, which stands for the limit, and c as the number. Let's just say that. Now we're going to go straight into our example. For the first example, you can see this is a limit, just like a straight exponential graph. And on the side, we're going to be doing the word problem for the limit. So it says as x approaches 4, right here, and we go to a graph, and this will be 4, right here. And you can draw the point right there. As x approaches 4, f of x is the y-axis will be considered f of x. So as x approaches 4, f of x is 2. A note for limits, they don't care what's around, jumping, a hole, or whatever the case might be in your graph. They just care what number it's approaching to. So a number cannot be there at all, and it will still be approaching that f of x. See, for the next problem, it'll be just asking about what f of 4 is. F of 4 equals 2. Now, if there was like a hole or a graph was jumping, it would be like undefined. But for now, it's the point for 2. So basically, you're just defining a point on a graph for this one. 2. So there you go. There's our answers for that one. To the next problem. As you can tell, as I was saying before, this graph has a hole. And it's in the same place as f of 4. So as x is approaching 4, f of x is, as x is approaching 4, f of x is still 2. See, for limits, they don't care. They do not care what's at the point, if the point is there or not, if it exists or not. It does not care. As long as it's approaching that number, that is your limit. And that would be 2. See, f of 4, now we're getting to the actual point. Since this is a hole, it will be does not exist, since it's a removable discontinuity. When it's asking for the actual f of 4 without the limit part, that will be, it's actually defining what the point is on your graph. So it would just be do not exist because it's a hole. And now as we go into the next problem, you can see your graph has a hole and an actual point. Once again, as x approaches 4, right here, it's 2. Because f of x is equal to y. So it would be 2. Again, limits don't care. As long as you're approaching that number, that is your answer. Now, if you're going to the actual point, since we're going here, and it has a hole, but on top of it, it has a point right there at, it looks like 5. That looks like 5. So your actual point will be 4, 5. It does exist. It's just not on the continuous line. So at f of 4 equals to 5. There. Now we're going to get a correct explanation using words. So as a limit approaches 1, which is right here, is approaching 1, f the function, I was going to say f of x, but we can say the function of x is 9. In parentheses, the y value. I just like to put that because it helps me by interpreting the graph better and by looking at my data correctly. See, I just did the whole entire thing, but we're gonna go back over. And I didn't realize I wasn't recording. But as x approaches 2, for number 1, it'll be -1, because here on the line, even though it's not continuous and it's a hole in this part of the line, it's still -1 because that is where it's approaching from both left and right. So you put -1. Now, if it was an actual point, let's say, okay, for this one, it goes in this one, the actual point, f of 2, it's not talking about limit, it's talking about the actual point. And if you go in your graph, you see the point is up here at 2, 1, as I put as the answer. Now, if the point wasn't up there and it was just a hole, it will be do not exist, because the hole means that point does not exist at that